Welcome to Study Loop.
So we have a styrofoam box of dimensions 25 centimeters times 35 centimeters times 55 centimeters. We'll write this as 0.25 meters times 0.35 meters times 0.55 meters. Now, there is 9.5 kilograms of ice inside it, which melts because heat from outside gets conducted into the styrofoam box, even though styrofoam is a relatively good insulator. The outside temperature is 34 degrees Celsius. The inside temperature is 0 degrees Celsius, which means the only heat needed to melt the ice is the latent heat of fusion. So the amount of heat needed would be mass times the latent heat of fusion. So we have our conduction problem. Q by T is equal to Ka delta T by the thickness. Also, we are given that the thickness of this styrofoam box is 1.5 millimeters. So let's use some other number for thickness, other symbol for thickness. Let's call it W, the width. So the amount of time taken is Q times the width by Ka delta T. We also know that Q is mass times latent heat of fusion times width divided by the conductivity of styrofoam, which is twice the conductivity of air, times the total surface area of the cuboid times the change in the difference in temperature. We'll substitute our values now. Mass is 9.5 kilograms. Latent heat of fusion of ice is 3.33 into 10 power 5 joule per kilogram times the width is 0.015 meters, corresponding to 1.5 millimeters, divided by K is twice that of air, so that's 2 into 0.023 joule per second meter degree Celsius, which is the conductivity of air, times delta T is 34 degrees Celsius. Now in the area, now we have 6 surfaces for this cuboid. Every two opposite sides are the same. So we want to find the area of this surface, which will be the same as the bottom surface. So we'll find the area of this surface multiplied by 2, then find the area of this surface multiplied by 2, then find the area of this surface and multiply by 2 and add them. So the area of the first surface would be 0.25 times 0.35 plus the second surface would be 0.35 times 0.55 plus the third surface would be 0.355 times 0.25, and this whole thing we multiplied by 2. So we have our time is equal to, by plugging in all these numbers into a calculator, we can see that this is equal to 3.6 into 10 power 4 seconds, which is 36,000 seconds. If you remember this, 1 hour is 3,600 seconds, which means our time is 10 hours. Notice that if we cancel our units in our formula, kilogram, joules, and degrees Celsius, and meters, there will be a meter square here. We will be left with seconds. That is why the units here are seconds.